So we will have an exam party for physics. I kind of explained last time. And you may have received an email from the LCC Physics Studio. And I just send this email with the QR code. And if you click that QR code, which is available here, just for the maps, okay? If you click this QR code, it does show you the schedule for exam prep party. If you cannot attend in person, it will be available. You can attend online. And this is going to be my schedule as well in the learning comment. So if you click the physics prep parties, the first exam prep party will be September 14, 12 to 2. If you can come in person, it will be in the TLC building, Learning Common, first floor. And the exam will be from 12 to 2, 12:10 to 2. And you can come in person, TLC building, first floor, Learning Common, in the Mass Studio. If you cannot come in person, so you can join online. In this link, if you click this QR code, you will see there is another link to join Physics Studio. Okay, Virtual Physics Studio, and we will. You can save this. Okay, so we will have a physics prep party for exam 1, 2, 3, and 4. If you would like, you can participate. I will try to record the session. And just in case, if you need a recorded session, you can send me an email. Okay, I will upload. I will send it to you. Yes.
Are we gonna have class after or when we finish?
No. When you are finished, okay, you are done. Okay, you can leave the class. So about the exam time, I am not finalized the exam time yet. Okay, but you will have multiple choice plus, blank space. So it can be, uh, you know, uh, uh, 60 to 90 minutes. Okay, 61 hour to 1 hour 30 minutes. Okay. So, so I recommend you to participate if you are prepping for exam 1. And yeah, all information you need is available here. If you just need to know my schedule in the learning comment, okay, you can click this link. It does show my schedule. If you would like to get some update about the prep parties, okay, you can subscribe or you can send me an email. Okay. This QR code, I think I already posted in your detail, yes? Or I send you by email, I don't remember. So today's class, let me just close this. Okay. Today we do the lab, Week 4, Newton's lab. This will be your first formal lab. You will run this lab in a group. You will have the same results, same graph, everything will be same, but you need to write your own report. So how the report is gonna look like? So if you open your D12, open the lab, here at the end of these, there is a formal lab. So your formal lab does have introduction, procedure, data, and analysis together, data and analysis together, discussion, conclusion. This is going to be the rubric. More details about the rubric is available here. I will explain, okay, what you're supposed to do in the introduction and then procedure, data analysis. But more details about this rubric, if you again open your, if you just you as a student, assignment, go here, go to the first lab, Newton's lab. Good. This is where you submit your formal report. But if you check in the introduction, I have explained what information you need to provide in your introduction part. So you will write your report in a Word file. Any graph, any picture, you will take a screenshot and then add it. Let's say if you have it, graph and table in the data and analysis part, you will take a screenshot of your graph and then save it as a JPEG. And when you are writing your report, you need to put these in the data and analysis part. And if you need to put a table, you need to use Word to create the table. Okay? I have explained all this stuff here, the rubric. So we will have an introduction. If you follow the level 1, okay, you will get 6 points. If you just follow the level 2 or you miss some explanation in part 1, okay, you will get 4 points. And then at the end, you will get 2 points. And the procedure, data and analysis part, again, I have explained everything that you need. During the experiment, you will see what kind of data and information you will have. So data and analysis part, and there will be a discussion and conclusion. The last part is language and format. If you follow the rules, which is explained here, you will get 4 points. Good. And again, there are level 1, level 2, and level 3. This is going to be the rubric. When you are writing your report, make sure to follow the rubric. And the exam, the formal report will have 25 points. Okay. So let's close this. Okay. Newton's law of motion. Before starting, I'll give you 10 minutes to read the introduction and try to answer the pre-lab questions. Good? So after 10 minutes, we will try to just answer this question and thus explain what you need to do in this lab and what exactly we are looking for. Okay, so go ahead and just read the introduction and answer the pre-lab question. Okay, so into the experiment, we have this equipment, track, bubble level to make sure that the level is, we have incline path, okay, not incline path, and computer, there is a laptop available in that box, okay, each table can grab one. Card, we have a card and a string with the hooks on both ends, weight, including the weight hanger and weight holder. As you can see here, we have a weight hanger and you can use these two form of the weights here, okay, one or this one. Good. So, and there is a card. This is a card, and this can play as a weight holder. Okay. So we are, and also you need a logger probe And Logger Pro software, Lab Pro, Smart Pulley. What is the Smart Pulley? You see this black wheel, okay, it's acting like a small pulley, a smart pulley. And then the rest is the Logger Pro logger interface. You make sure that the logger interface, this a smart pulley is connected to logger interface. Yes. And then connect this logger interface to the laptop. And then open your logger. Make sure to open the pulley. Good. It is explained in the lab report. Okay. So in today's experiment, we are trying to find the to uh, 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 play with the Newton's second law. What is the Newton's second law? What is the Newton's second law?
Video rewrote it. Like it was, it's not F equals M. Difference. Like they did a different thing.
Acceleration is equal to net force over m. Good. If you check your D12, let me just show this, okay, and then. Okay, if you go to your D12, click the content, and there is an extra link and resources. Good. You see, there are some videos in Dr. Christine Viscosi YouTube video. You can watch these, okay, and also you can watch my videos as well. Ali Orbanpur's recorded lab and lecture. I'll just record my in-person class and will put everything that I record in this folder. Every week you will see more recorded lecture. For instance, today I talked about the Newton's law of motion lecture. You can watch this lecture. I have explained a lot about the Newton's law, first law, second law, and third law. Make sure to watch this recorded video as well. Good? Okay, let's back to sigma F is equal, A is equal sigma F over mass. Are you on that? Okay, A is equal sigma F over mass, okay? So, and then what is the sigma F? It is net force, okay? Net force which is exerted on a system. Net force that brings the system to the motion, okay? So if we have an object, if we exert force, this object will accelerate. If no force is exerting or there are forces, they are canceling each other, the net force is going to be zero. When the net force is zero, it means that there is no acceleration. Let's say we have a pushing force and there is another force. How many other forces that we have here? Yes, support force and force of gravity. Yep. Okay. Good. And if you have friction, which we have explained, okay, in your D12, in the PowerPoint, so the friction, if the system move forward, the friction will be backward. Good. So if this system move, if this block move, what does it mean? It means that F push is bigger than friction force, yes? How about the horizontal forces? The box is not moving up and down. What does it mean? The net force in the horizontal, in the vertical is zero. So net force in vertical is zero. Good. So it means that force of normal force is equal to the force of gravity. But the system in horizontal line, Okay, sigma F in horizontal is not zero because F push is bigger than friction force. Okay, how we can calculate the acceleration of this system? We can say acceleration is net force in the direction of the motion, all net force in the direction of the motion divided mass of the system. Okay, so what is the net force here? F push positive, F push. So let's see. F push positive plus what is the friction? Negative, yes? Because it's in the opposite direction. Negative friction divided by mass of the system. This is how we can calculate the acceleration of the system. Acceleration is equal to net force divided by mass of the system. Yes.
Maybe kind of a dumb question, but how do you know what the friction force is?
We can calculate. So in this physics, you don't need to calculate the friction force. If the system does have friction force, the number will be provided. Good? Yeah, we can calculate, okay, but you don't learn in this physics. So, and the friction force is a resistive force. It means that it is a force that is opposing the object from motion. If the object moves forward, definitely the friction force is going to be backward. So, here, we are trying to find Newton's second law. It is a sigma F over m. We are trying to find the relation between the acceleration and mass. Good. So what was the first question in the lab handout? What is the independent variable? Yes. The weight on the card, okay. What else? Mass on the card, yep. On the card, yes.
Yeah.
Good. What else? The hanging weight. Okay. No more? So let's see what we have. We have a incline path. We have a pulley. Good. And there is a rope. This is a card, yep. And this is a hanging object. I call this M and this capital M. Good? Okay. And I'm just trying to see what is the acceleration of this system. How I can find the acceleration of the system here? What is the formula? Acceleration is equal net force divided by mass. So it means that I need to identify all forces in the system. How many objects of interest I have? Hanging object and the card on the level, yes? So, and I start with this one. How many forces is exerted here? Two. Okay. It is a force of gravity, which is the mg. Okay. And what is the other force here? Tension force, or we call it Ft. We assume that the car doesn't have any friction with the level, okay? In this experiment. So how many forces are exerted on the car? Tension, normal force, yes. Force of gravity. If there was friction, okay, that would be in this direction. Yep. Okay. So I say these two objects are considered as a one system. If you check the PowerPoint, I talked about the systems, okay? Two objects in one system or separate system. Even is available in my recorded lecture. If you want, you can watch. So one thing, this system move or not? If we set up this system, what do you think? If we release this M, the system does move or not move? It definitely moves. So it will accelerate.
Yeah.
I would like to use a trick to calculate the acceleration. What is my trick? I'll take this M out, no hanging weight. What happened to the system? Does the system move or not? Yes? So what does it mean? It means that the reason that this system is moving is because of the hanging weight. Yes? What was the acceleration definition? Those forces that cause the system to move divided by the mass of the entire system. Good?
The independent variable.
One more time. So what is the net force? What is the net force? No, let me just write the equation and then you will find out. Net force here, we said that if there was no hanging object, the system doesn't move. If we hang the object, the system moves. What does it mean? The reason that the entire system is moving because of the hanging weight. What is the net force then here? The weight of the hanging object. Good? mg. What is the mass of the entire system? M of the hanging object plus M of the card. Okay? Not now, okay, so I just say M, okay, and then we can just use different number. So look at the acceleration and mg divided by mass of the total system. So here is the mass of the entire system, good? And the mg is the weight of the hanging mass. If we want to find the relation between the acceleration and mass, which one is better to change? Is better to change the weight or is it better to change the mass? Because we can just keep this constant, yes? If we just keep changing this, we cannot find the relation between the acceleration and mass. If we keep this constant, what does it mean? It means that the weight of the hanging mass, we keep it constant, but we just play with this mass, okay? Mass of the card. Whatever is inside there, the mass of the card, whatever it is inside the card. Good? That's how we can find the relation between the mass, acceleration, and mass. And how we can graph this? We can say mass and acceleration. What is this variable? Independent, yes? What is this variable? Dependent. So why? Because by keep changing the mass of the system, okay, the acceleration will change, okay? So independent is not the weight, okay? It is the mass of the card and whatever is inside the card. Okay, we just keep the mass of the hanging weight constant. And we know why. So what was the next question? Dependent, we just explained. Okay,
Right.
by keeping changing this, what is going to change? The acceleration, because this value is constant. Okay, This is a constant value here. Let's say this is 100 divided by changing value. Good. So what is the next question?
For the variables that you know,
Okay, we just explained. What?
I mean, that was my question.
Okay. What is the variable that we control?
I just know.
Mm-hmm. Mass of the car. This is something that we control, yes?
Yeah.
Okay. But by controlling the mass of the car, okay, we would be able to see how the acceleration is changing, yes? So what is the next one? Write the hypothesis, include what is in control. Okay, I just explained this, okay? And sketch what a graph of the acceleration look like. How the acceleration of the graph of the acceleration versus time look like. What do you think? Based on this equation, how the acceleration and mass is changing?
As the mass of the car goes up, the acceleration speed, well, the amount of time it takes to fully accelerate will,
The mass increase, the acceleration increase?
or acceleration.
No. Okay, you see here, if we keep this constant, if the weight of the hanging mass is constant, by keep changing the mass of the car, you are increasing the mass of the system. Good? By how the acceleration and mass are related to each other, they are related inversely. Good? Equation sigma f and m. How mass and acceleration are related? Mathematics. This is constant, yes? If you just, let's say, increase this, what happened to this number? The acceleration decrease. Let's say we have 1 kilogram, yes? And this is 100. 100 divided by 1 is going to be 100. If just increase this to 2, what happened? 100 divided by 2, yes, is going to be 50. What happened to the acceleration? Decrease. Good. Acceleration and mass are inversely related to each other. Please review the PowerPoint, okay? So acceleration and mass are inversely related to each other. By increasing the mass of the system, acceleration decreased. So what happened to this graph then? If you increase the mass, okay, the acceleration decreases like this, yes? And how they are related? They are related inversely. Okay? So today your job is to find out about this graph. Okay? So what you are supposed to do, you have a hanging object, hanging weight, and you have a card, and you can just keep changing the mass of the card by adding weight or decreasing weight. It is explained in the left handout. When you decrease, you calculate the acceleration. The logger pro will calculate the acceleration for you. And just keep decreasing, you will get new acceleration. What you do, you will have a table. And this table is going to be the mass and acceleration. Good? Then you will go to the logger pro and graph mass and acceleration. When you graph the mass and acceleration in the logger pro, you will have these points. Good? And if you read the lab handout, it's telling that the logger pro has a curve fit function. You can connect these points together. Good? So for connecting these point together, we use the a equal x. What is this function? This is a curve fit function, and this is an inverse curve fit function. So acceleration, x-axis is going to be mass, y-axis is going to be the acceleration, yes? And you remember what was the formula? A was equal sigma F over M. When you compare these two equations, what does it mean? A is the y-axis, X is the M, and what is the sigma F? This is the curve fit value function, the constant value of the curve fit function. What is this value exactly? Net force. What was the net force? The weight of the hanging object, yes? If you run the experiment and this value become almost equal to the weight of the hanging object, it means that your calculation, your experiment is good. If there is a difference, this difference should be less than 10%. Good? Let's say this is a pulley and this is 50 gram, and you just keep playing with this. How we can calculate the weight of the hanging object? What is the weight formula? What is the weight formula? Mass time acceleration. What is the mass here? 50 gram, yes? Converted to the kilogram is going to be 0.05 kilogram. 0.05 kilogram times 9.8. So what is this value will be? Point 0.05 times 9.8. It will be 0.49. The weight will be 0.49 Newton. Okay? So when you do the curve fit function in the Logger Pro, the A that you are calculating should be almost 0.49. If this value is smaller than this, that's all right, but it should not be less than 10%. It should be less than 10%. More than 10%, it means that you need to redo the experiment. Okay? So, and what is the Logger Pro? I will show you right now here. How we can use the curve fit function in the Logger Pro. Let's go and open the Logger Pro. And when you open the Logger Pro, okay. Let's say you run the experiment, you have your table. There is a table in the lab handout. Mass and acceleration. You will come here and you just will say that the acceleration is X is the mass. You can go and just change it here. Mass. And then Y is going to be acceleration, yes? Okay, so we can change this. Okay, so X is the mass, okay, Y is the acceleration. Let's say I'll just put the just random number here, okay? So 1 acceleration become 1, 2 acceleration become half, 3 acceleration become 0.3, but you will have your own number, okay? So 4 is going to be 0.25, 5 will be 0.2, and then that's it. So what I do, I am supposed to use the curve fit function, okay? Make it this, I just make it a little bigger. But what I do, I'll go here and select the entire thing. You see here, there is this one, okay, this symbol, it's a curve fit function. You click the curve fit function, and there are a couple of equations here. but we know that the acceleration with mass is changing inversely. Yep. So which function I should select? Not linear, not quadratic, not cubic. Okay, I'll go and find the inverse one. A over x. I click this. What exactly this curve fit function does? Connect these points together. Okay, so try to fit. It will give you this number. Okay, so y is equal a over x. A is 0.99 here. Your a, good, should be almost equal to the weight of the hanging object. I just showed you how it should be equal. If it was equal, it means that your calculation is completely okay. So if it is not equal, this error should not be bigger than 10%. Okay, the difference should not be bigger than 10%. If it is bigger than this 10%, okay, it means that you need to redo your experiment. Good? This is how we find the relation between the acceleration and mass. You can right now start the experiment, but let me just see, okay, do I need to explain anything? Yeah, follow this procedure and then complete this table. For each mass, okay, you will supposed to do the 3 trials. And how you can find the average of the acceleration? Adding this acceleration and dividing by 3. Good? So complete this table, and when you complete the table, this is going to be your mass of the entire car. It's going to be x-axis, y-axis is going to be your acceleration. And then the rest is just do the analysis. Okay, you can start the experiment right now.
I don't